The Apollo 8 mission of astronauts Borman, Lovell, and Anders was the culmination of 8 years of manned spaceflight. From the 6 manned flights of the Mercury program through the 10 manned missions of Gemini, the development of manned spaceflight in the United States had proceeded with an elegant logic to the threshold of manned Apollo missions in the second half of the year 1968. But as this period began, the final crucial steps still had to be accomplished before Apollo 8 would reach this point, 3 hours before liftoff on its history-making voyage to the moon. First of all, the spacecraft itself had never been flown with men aboard. A manned Earth orbital flight test was essential to man-rate the command and service modules before the ambitious lunar orbital mission could be attempted. Apollo 7 was designated to be this indispensable mission, the first manned flight of the Apollo spacecraft. The prime crew consisted of astronauts Walter Schirra, commander, Walter Cunningham, and Don Isley. The mission's objective would be to prove that the crew and the command and service modules of Apollo, with all life support and other systems, would function in space long enough and maneuver well enough to carry men to the vicinity of the moon and back. The mission was planned to have a duration up to 10.8 days. Liftoff was scheduled for October 11. But first, the crew would have to complete their training for the mission, and launch vehicle and spacecraft would have to pass all final tests and checkouts. Apollo 7 would not carry a lunar module, but it would take into orbit the spacecraft lunar module adapter. On the unmanned Apollo 6 mission in April, an adapter had partially failed. Vibration tests and other studies revealed that the failure probably was not the result of launch vehicle-induced vertical vibrations or pogoing as originally surmised. The adapter's structural weakness was remedied by drilling holes in the section to relieve stress and by adding cork to additional areas of the panels. The adapter and the Apollo 7 command and service modules were mated to a Saturn 1B launch vehicle at Complex 34 of Kennedy Space Center early in August. System tests and crew training continued. The Apollo 7 prime and backup crews logged 320 hours in the command module simulator in the third quarter of the year. By mid-August, the crew had completed water egress training. And by mid-September, they had trained in various modes of launch pad escape. They also participated in manned altitude chamber tests of the spacecraft, countdown demonstration tests, and the Apollo 7 flight readiness review conducted on September 20th. Other system tests, such as parachute load tests and water drop tests, were completed by mid-September. On schedule on the morning of October 11th, the Apollo 7 crew boarded their spacecraft. takeoff occurred just 2 3/4 minutes after the target launch time set months before. Apollo 7 was on its way. The precision of launch was matched throughout the 11 days of the mission. It was a textbook flight. All systems, including those being tested by men in space for the first time, responded perfectly. For instance, the second stage of the Saturn 1B vehicle is the Saturn 4B, which is the third stage of the Saturn 5 lunar mission launch vehicle. Apollo 7 maneuvers proved that the spacecraft could be controlled when attached to the S-4B stage. The ability of the spacecraft to separate from the S-4B, turn around, then dock with the lunar module was confirmed by a successful maneuver and simulated docking. The adapter attached to the S-4B is seen here. In future missions, instead of being simply sprung open, the panels will be jettisoned before the lunar module has been linked to the command and service modules. The first Apollo rendezvous exercises were performed using the service module's main engine to propel the spacecraft back to the S-4B after they had drifted apart. The main engine was burned a total of 8 times during the mission with complete reliability. Other systems also proved their reliability: guidance and control, navigation, life support, electric power, food and water, communications, ground network tracking and control. The Apollo 7 mission not only justified the confidence of astronauts, engineers, and technicians in their equipment, the mission also revealed more benefits than had been expected from the habitability of the Apollo spacecraft. Several times during the mission, the flight crew televised their activities to mission controllers and to the millions of persons watching from their living rooms on Earth. As can be seen, the command module is commodious compared to previous spacecraft. It has 4 times the space to move around in that Gemini had. Not only mobility, but the ability to perform work while weightless was also greater than expected. In the in-flight coverall garments worn during most of the Apollo 7 mission, weightlessness made most activities easier. The added mobility plus regular onboard exercises performed by the crew also contributed to their basic physical health. Post-flight biomedical examinations revealed no loss of calcium and generally far less muscle bone system deterioration than after the long Gemini flights. Re-entry and recovery of the Apollo 7, like the entire mission, was as planned, 10.8 days after liftoff, more than enough time to go to the moon and back. The mission was called 101% successful. The Apollo 7 triumph of men and machines in space added new stimulus to an already accelerating momentum felt in the manned space program as the year 1968 raced forward. Analysis of Apollo 7 performance supported the decision to program Apollo 8 as a lunar orbital mission, and training and testing proceeded toward this goal. Launch was scheduled for December 21st. In keeping with the policy and practices of NASA since its formation as an agency 10 years previously, everything at the Manned Spacecraft Center did not come to a halt to make way for the next manned space mission, however vital it seemed. Just as the manufacturing and assembly of several different spacecraft continue simultaneously in various stages toward completion at the plants of contractors, training of crews and development and testing of spacecraft continue side by side on projects as widely separated in time as the Apollo 9 mission set for early 1969 and the orbiting space stations planned for the 1970s. For example, the Apollo 9 mission was scheduled to be the first manned lunar module mission, with astronauts transferring between the command module and the lunar module, both inside and outside of the spacecraft. Apollo 9 crews trained extensively in simulated weightlessness underwater, making the EVA transfer between modules. The transfer entails the first outer space use of the Apollo Extravehicular Mobility Unit, or EMU, consisting of pressure suit and life support packs. The EMU was checked out in several altitude chamber tests in the report period. The Apollo 9 mission was also supported by several equipment tests in the report period. Latch load tests were completed. Flammability tests were completed in early August. Docked modal tests were conducted on August 15th and September 26th. And the Apollo 9 lunar module successfully underwent both unmanned and manned altitude chamber tests in September. During the same period, the development of equipment for advanced Apollo applications programs continued. Here, in a KC-135 aircraft, subsystems of the Apollo telescope mount are tested in brief maneuvers of weightlessness while crewmen check out handling characteristics. The Apollo telescope mount will carry solar telescopes and spectrographs for observing dynamic phenomena on the surface and in the corona of the sun. It will be an important tool for an orbiting workshop. Another category of tools to be used by orbiting space stations are those that will study the Earth. For example, photographic, radar, and infrared sensors are being perfected and tested by teams in MSC's Earth Resources Aircraft program. When perfected for spacecraft application over vast areas of the Earth, such sensors will detect temperature changes in soil and water, revealing subsoil structure and composition, and data from oceans and rivers, such as the amount and variety of sedimentation. Of more immediate application as the lunar landing program accelerates, the Lunar Receiving Laboratory was reviewed and certified as operationally ready in the report period. Astronauts from the first moon landing mission on will be transported by special van to this building for a period of quarantine. Here they will undergo detailed physical examinations, living behind a germ-proof biological barrier until the end of the quarantine period. Samples obtained by the astronauts from the surface of the moon will also be isolated and handled remotely in vacuum chambers until the slightest possibility that they might contain bacterial or other life forms has been ruled out. But as 1968 approached its end, we still had to learn whether we could reach the moon or not. The Apollo 8 mission proved that we can. This was its technological significance. Let's review some of the final preparations of crew and spaceship before that memorable liftoff on December 21st. The big concern about the Saturn V launch vehicle had to do with the pogo effect, excessive longitudinal vibrations that were set up by the 7.5 million pound thrust of the 5 first-stage engines in the April Apollo 6 unmanned launch. Launch vehicle engineers licked this problem by adding a helium cushion to the cavity in the liquid oxygen pre-valve area. This broke up the sonic pressure pattern, reducing resonance and vibration. We have already shown how the adapter's structural weakness was remedied. Within the adapter, Apollo 8 carried a Lunar Module Test Article, LTAB, rather than a lunar module. This dummy lunar module and other Apollo 8 modules were mated with the vehicle early in October. Manned thermal vacuum tests in Chamber A of MSC's Space Environmental Simulation Laboratory were conducted in September on Test Article 2 TV1. Operation of subsystems and the thermal design of the spacecraft were verified for lunar orbital environments. The Saturn Apollo 8 space vehicle was transported from the Vehicle Assembly Building to Pad A of Complex 39 at Kennedy Space Center on October 10th. Pre-launch testing and final preparations over the ensuing 2.5 months revealed practically no problems. The ultra-cold liquid oxygen supply for the spacecraft fuel cells somehow became contaminated with nitrogen from the chilling tank. But the supply was drained and replaced, and the risk of repeated contamination avoided by substituting cryogenic oxygen for nitrogen as a chilling agent. Other very minor problems were easily overcome, a tribute to the engineers and technicians who built the complex 36-story high spaceship. The last major step in pre-launch preparations was to complete the fueling of the 3-stage launch vehicle. Fully fueled, Apollo Saturn V contains over 5.5 million pounds of propellants, with a total thrust capability of almost 9 million pounds. At about 5 a.m. Eastern Time on the morning of December 21st, the flight crew boarded the spacecraft. During the final countdown, thousands of men, computers, ships, aircraft, antennas, and other components stood ready to support the 3 astronauts on their voyage. In addition to launch control at the Cape and mission control at the Manned Spacecraft Center in Houston, there was a support network of 14 ground stations, 6 tracking and communications aircraft, and 4 naval vessels, including the carrier Yorktown, cruising in the primary recovery area 200 miles south of Hawaii. Apollo 8 was launched at 7:51 a.m. It was the beginning of a flawless 6-day mission. By television and radio throughout the world, the people of the Earth traveled with the 3 astronauts. They reached the moon at 5 a.m. on the day before Christmas, coasted around its leading edge, then behind the moon, out of touch with Earth, they fired the service module main engine. A 4-minute burn inserted the spacecraft into lunar orbit. A second burn circularized the orbit at about 69 statute miles above the moon's surface. For 20 hours during 10 orbits, the crew observed the craters, seas, and mountains of the moon, sending back pictures and explanations to their enthralled fellow human beings 230,000 miles away. On Christmas Eve, the three pilots performed their reading of the first 10 verses from the book of Genesis, closing with this greeting from Commander Borman.
And from the crew of Apollo 8, we close with good night, good luck, a Merry Christmas, and God bless all of you on the good earth.
The firing of the main engine to start the mission on the homeward flight path also occurred behind the moon. There were anxious minutes as flight controllers and millions of spectators waited for the spacecraft to round the edge of the moon and resume contact. Finally, telemetry made contact. Shortly thereafter came the voice of Apollo 8's navigator, James Lovell.
Apollo 8, over.
Hello, Apollo 8. Loud and clear.
Roger. Please be informed there is a Santa Claus.
Technically, the objectives of the mission were completely and successfully accomplished. After the Apollo 9 and 10 missions verify lunar module and EMU functions in the first half of 1969, the United States will be ready to place men on the surface of the moon. In introducing the three Apollo 8 astronauts to the United Nations Assembly, U Thant said, "Truly, they are the first Universalists." A wise observation, for philosophically, too, the Apollo 8 mission had a special significance. It is summed up best, perhaps, in the words of Archibald MacLeish, quoted by Frank Borman to the joint session of the United States Congress, and by President Nixon in his inaugural address. To see the Earth as it truly is, small and blue and beautiful in that eternal silence where it floats, is to see ourselves as riders on the earth together, brothers on that bright loveliness in the eternal cold, brothers who know now they are truly brothers.